Okay. Suppose the pendulum bob shown has a mass of 0.33 kilograms and is moving to the right at point B with a speed of 2.4 meters per second. Air resistance is negligible. First part, what is the change in this system's gravitational potential energy when the bob reaches A? So as it's going from A, or from B here to A. Okay. Now, we're looking for the change in gravitational potential energy. So what does change mean symbolically? Delta. And what is the symbol we use for gravitational potential energy? U sub G. Okay. So what is the equation for the change in gravitational potential energy? Mgy minus Mgy naught. Okay. Now let's see. This is a final position, so this would be at point A. This is an initial position right here, so this would be at point B, because it's going from B to A in this case. So what do you want the height at point B to be? What do you want to let this be right here? Y equals 0. Sure, and that'll be our initial height. Okay, so then what about at A? What's that? It's going to be some Y. Okay, now we need to figure out that Y. It is the height that's like here. I need to figure out that height. So I'm going to redraw my picture, sort of. And so here is the string, 3 times apparently. And then here is the string when it's at A. Now the string has a length, and I'm going to call it L. And the L doesn't change no matter where it is, the string is the same length. This is the angle that it swings through, that's our theta right there. Now, I'm going to drop a perpendicular from where point A is all the way back down to the vertical line there. And this will be my Y. So I'm just going to kind of shade it. This would be Y. That's the height above Y equals 0. So far, so good? Okay. Now, that right there would be the same as this piece of the whole length of the string. So this whole length right here is L. Now, can you find this side of the triangle right there using L and theta? Is it adjacent or opposite? It's adjacent. So what function do we use for adjacent? Cosine. So I'm going to call that side D. D would be equal to L cos theta. So this blue section right here, I've labeled D. So what's Y in terms of D and L? If Y is this little red piece, L is the whole thing, and D is the little blue piece, L minus D. And what's D? L cosine theta. So mg and then L minus L cos theta, 1.2. Wasn't that the length of the chord from the picture? And the angle was 35 degrees. And then what was our initial height? What was our initial height? 0. So what's the initial potential energy? 0. So then the final change in gravitational potential energy is 0.72 joules.